Welcome to DefN episode number 28. This is Vijay from the Netherlands.
And it's Ray from Belgium.
And it's Max Penet from, Switzerland, but in Sweden.
Hello, Max. I thought we were going to introduce you, but anyway.
Okay. You just get there.
You just popped in.
That's awesome.
That's pretty nice. Anyway, it's Christmas time, so everything is okay. Is it Christmas or holidays?
I didn't get
it. We say anything that will upset Donald.
Yeah.
so happy holidays then.
So fuck Christmas. Yeah.
Okay, that is
Sorry,
going to offend like pretty much everybody now. But
well,
I mean the just before before we started recording, Ray, you're talking about Advent of Code. That is holiday thing, right?
Yeah, I mean, we can dispense with all the commercial bullshit, but yeah, we can do the Christmas of Code. Yeah, the Advent of Code. That's good. Yeah. Okay, yeah, so Advent of Code. Yeah, a few of the Clojure guys are doing it, and this guy, I think you know him. Is it Michael Bork?
Yeah, Michiel Borkant.
Yeah, right, him.
I think you're anglicizing his name.
Bork Dude, at Bork Dude on Twitter.
Yeah.
That's his proper
But there
name.
are plenty of people doing this one.
Yeah, well, he's made a repository with about, I don't know, 20, 30 people that are doing it. Like, and there are various people. I think Bruce Howman and friend of the show, Mike Fikes, is doing it as well.
Yes.
And he's doing it in bootstrapped Clojure script. So I think there are people doing it in different kind of forms and different ways,
Awesome.
But I was looking at it and I was thinking it was very interesting because if nothing else, you can learn some tidbits about Clojure as you go along and compare the styles of people. As one example, there was one two examples. Okay, two examples. One quick example that I know that Michael and Mike were talking about was the difference between nth rest and drop. It was on Twitter's and apparently it said that drop is lazy and nth rest is not.
It's holding onto the head apparently.
Yeah. Then the other thing that I saw in Michael's code actually was plus prime. Where you say reduce plus prime. It's something I've seen it in the code before, but I'd sort of ignored it and I thought, what the hell is this? And then I finally thought, okay, screw it, I'll look it up. And it's this one where it goes back to pre-Clojure 1.3 behavior, where it promotes the numbers to so that you can have arbitrary precision.
Yeah, it's two big decimals or big integers. Yeah.
Yeah.
Yeah, but these are the things that you generally don't get to unless you need a specific use case or something.
Yeah, but it's interesting as to why do these guys put this stuff in there, and I don't know. Just to me, it was quite kind of interesting to see the code that they're writing, and you can. I guess you can have a little discussion about that. I don't know if you've done anything like that yourself, Max. Maybe these coding
no, plus prime.
competitions?
I've never heard about it actually. I was wondering what it is. Well, in one of the libraries I authored, there is some like unchecked math and stuff, but I mean. It's just to iterate a bit faster over some data structure. In general, no, I don't use these kind of low-level things, to be honest. Don't think.
Yeah, I think anything that it's a sort of distraction, isn't it, from the code? You have to have a very good reason to use it.
Yeah. Usually I start simple, and then if I really have to, I go down to these the gory functions that you never use.
The
unchecked stuff and. And really sometimes if I really have to down to Java, but it's kind of rare these days.
Down to Java.
yeah, it's like assembly at this point, Java for us.
Yeah.
This is the first time I'm hearing somebody saying down to Java. It's like using Java as an assembly language or something.
Yeah, but that's not uncommon. I've heard that a couple of times in the past from other people doing Clojure. I can't remember who was saying that, but you get the best performance you could get on the JVM more or less using Java, and from Clojure it's kind of rare that you have to go that low level. Zach Tellman, for instance, has done that a couple of times for primitive math and a couple of things dealing with byte streams and so on. But the vanilla, the normal Clojure user, let's say, if we can say it like this, doesn't really have to go so low level.
So I think this is a nice time for you to introduce yourself, Max,
Yes.
and then talk about how did you get into Clojure.
Yeah. So what should I start from? From when I started using Clojure, or so I'm Max. I live in in Sweden. So I used to. Well, I'm from Geneva originally, so I moved here like 3 years ago, and I work for a company that's in Switzerland still. So I work remotely mainly, and yeah. So I happen.
It's not really a big. It's not really a big upgrade, right? I mean, going from Switzerland to Sweden.
I mean, for me, it's kind of a downgrade from many things. I mean, the weather's not as good, let's say, as the one in Geneva.
Exactly.
Not that the one in Geneva is like tropical and nice, but yeah, here it's it's a bit worse. And there's the light. I mean, I'm not super happy about Sweden in general. Let's say living here. So
don't you get if the skiing is a bit easier there, isn't it?
The skiing, it's a bit flat around here. So I used to bike a lot, for instance. So I was big on like going climb some mountain or some hill in the weekend with my bike, but now I cannot really do that. The best you're gonna get is the wind hitting your face really hard on a flat section. So yeah. No, other than that, I mean, there's worse place to be for sure. It's nice for many things. Cannot complain too much. But yeah.
Why did you move there then? Come on, I mean,
because the work of my wife, she works with particle accelerators, and there are not many around, and it happens to. I mean, they're building one around here, so we're here for as long as it lasts. And then
is it the same big one that goes under the entire Europe, and then you're going to the other part of that one, or is it actually a different particle accelerator?
I don't think there's one that big. There's one close to Geneva. I mean, in Geneva. Which is CERN, so it goes under part of France, part of Switzerland, but I think it's like 30 kilometers in diameter, if I'm not wrong, or a bit less. But that one is a linear one, so it's straight, and so it's a bit different. But they're building it from scratch, so for her it's super interesting to be here, and I mean, she does research on this stuff, so she gets to put her hand on the process from scratch instead of So we're here for that.
I think we should get her on the podcast at some point.
Yes.
I bet she programs in Python though, or something.
She uses awful stuff. Mostly old code from the Fortran stuff and bastard programming languages that came out of awful stuff. I did use some Clojure for her in the past. I helped her with interop through GNI with Clojure. I mean, another level of but
that's true love. That is.
Exactly.
That is,
So that's the best I can do to help her. Then it goes to crazy math I don't even understand, or physics stuff that's like, way over my head.
Okay.
Nice. So that's why you ended up in Sweden. And then, but before getting into the Clojure stuff, what were you busy with?
What am I busy with?
Yeah, I mean, which languages that you use?
At work we use Clojure. So I mean, mostly Clojure. There is we use a bit of Erlang. We did use a bit of Erlang in the past. Well, it's still in use actually, but it's more like running and hasn't been touched in a long time, and it's doing just fine by itself now. But it's mostly Clojure. And
what about in the past though, Max, when you first started programming?
Oh, well, it's been a long time, so I've used a bit of everything, to be honest. I started very early with Amiga stuff, so assembly and all this stuff, and then through university. Actually, the first language I was introduced to at university was Java. Java and Emacs together were when I remember. So it was in like end of the 90s. So Java was not so well developed, let's say. It was a bit of a pain to use. There was no real IDE like there is today. And then through work, a bit of everything. It went a couple of variants of VB, a lot of Python. And then there were the startup days where I was like hopping from one to the other, and it was mostly Python before Clojure, I would say.
So what made you come to Clojure, Max? What made you fall in love with the parentheses?
I was a bit playing with a couple of Lisps. One of them was called, I think, was called WASP, and it was something related around security. It was basically allowing you to build distributed system, we can call that like this, but it was a bit more oriented around security in general. And it was like a very experimental thing, and I got hooked. I mean, I just realized that the parentheses thing actually, the structure of the language was really nice. And from there, I tried Common Lisp, and then Clojure came out, and I think it was on Reddit, I discovered about it, and then tried it in the early days, which was, I don't know, I think it was around version 1.1, something like that. So yeah, 2010 probably.
Yeah.
And
Wow.
yeah, so I was using it basically on the evenings after work. And the startup I was working for at the time basically closed down, was not doing so well, didn't get any another round of investment. And I was working on this little toy project on the side in Clojure, and I showed it to one of the owners of the company back then. And he used that as a buoy, I would say. It was like the way to, he sold that to clients, and from there we created another company, and that company became the one I work for now, let's say after 5 or 6 years. Then we merged with another company and so on, but that was how it started.
Okay.
Well, I hope they give you some shares, Max.
Yeah, well, it's we are doing okay, but we're not Microsoft big or Google big.
But which company is this?
It was called Shareware at the past, but now it's called Affinity.ai. But it's the company, it does a couple of products, some of which are a bit more known than others. One was, we merged with the company that used to build paper.li, which was, maybe you know about it. It's this service where you can basically set up an environment where you get your own newspaper published every day.
It's a bit like what Prismatic was back in the day.
Kinda, sorta, yeah. It's similar in some way, but it's maybe less focused on one thing like Prismatic was. It's a bit more broad, the scope. And it's just one project. Because our side of the company was working on other things. We were working on some knowledge center kind of product where you ingest tons of data from whatever source you get, and you give the tools and the UIs to the people in charge to basically drill down this data and figure out what's what. So some people use that for alerting, some people use that for other things like conferences to show fancy dashboards with tons of graphs and things moving in real time and these kind of things.
Okay.
So yeah, it was more oriented about iCandy, this product specifically. And when we merged with the development team that's behind Paperly, we basically created a couple of new things. And so there's a lot of data science now behind the scene. There's a lot of data aggregation. I don't know if I have a couple of numbers. I think we analyze, we get 500 million posts per day. And it's like 30 or 50,000 articles that are analyzed per day. Millions, not thousands. And so when I say analyze, there's a lot of, entities detection, categorization, sentiment analysis, and all these kind of things. And all of it is written in Clojure. So
you're a kind of Clojure version of Google News.
Yeah, it's a bit similar in some ways. But I would say we have more, we focus more on allowing the users to have very precise querying capabilities. We have like our own little programming language that they can use, and they can express very complicated queries and do like custom weighting on a lot of things through subqueries. And so the users that we have, the like private companies that use the thing, typically there are people who want to know what their competitors are doing, or when there are early funding happening in their domain. But it's very often extremely precise. Okay, I'm in medtech, but I'm interested in all this specific field. And
But so before we get, I would love to discuss more about the stack that you're using. But I'm curious about how do you type all this shit and in which editor? So
it's maybe it's gonna surprise you, but I'm an Emacs user.
See, I knew it. I mean, it's really difficult job. So you need a proper IDE for this.
Exactly. No, I wouldn't be possible without Emacs. No,
it wouldn't be possible without Emacs.
No, Emacs now it's yeah, it's been a long time. There was a little hiatus where I didn't use Emacs for a couple of years, but then I quickly went back to Sanity and just yeah. No, yeah, at university we were introduced to it. So
yeah, like for 2 years I was insane, and then I came back and everything is fine again.
Yeah.
And then I started using Emacs.
Yeah, it really does feel like a religion to me, but okay.
I think it's I don't know. I think you get used to so many things that it's hard to go back to something else.
Yeah.
Unless you really have to for some reason. I mean, I was playing with Kotlin, for instance, a couple of months back, and I mean the IDE is so well done that and the Emacs integration is so poor that I mean in that case I understand it doesn't make sense to use Emacs. I mean, at least for now. Then just wait a couple of years and who knows. But yeah, at the beginning I hated it.
Well,
at university.
Kotlin is a little bit kind of it's got an unfair advantage, hasn't it? If it came from IntelliJ, so
Yeah.
they're kind of like definitely privileging their IDE.
Yes, that's exactly that. And I mean, it's extremely powerful. I mean, you can basically convert normal Java code to Kotlin in one click. And, I mean, you can do crazy stuff. It's but then you have to live with the rest of the IDE, which is not so nice in my opinion.
Right. Okay.
Yeah. But
so you also use your own keyboard.
yes. Well, it's not my own. It's the one that was designed by Phil Hagelberg, actually, the guy behind Leiningen.
Oh yeah.
So
yeah.
But yeah, I've been using for quite some time also mechanical keyboards in general, and with time, as time passes, it seems like they shrink down a bit more. Started with a full-size keyboard and 10 kilos, then a 60%, and now I'm down to the Atreus, which is the one that Phil designed. And yeah, it's an open source design, so it's really nice for that.
Yeah, because I've been lately dabbling or kind of thinking about getting one of those keyboards because I saw Arne browser. He got this Ergodox DX or something.
Yes.
Then I've been itching to get one of these keyboards, and one of my colleague, I work at Workspot, and one of my colleague, our software architect Marine, he 3D prints his own shit. So he's just 3D printing his keyboard, and it's like super. I mean, very ergonomic actually.
Yeah,
like it's a butterfly design, so it's a split things.
Yes, exactly. But I think when Phil designed that keyboard, the main goal for him was it had to be very ergonomical. Because I don't know if you've seen, but Phil is the guy who used to like wear pants with a keyboard split on each side of the pant, on one leg on one side and on the other. So he could basically work standing with a split keyboard on sticking on his pants. Anyway, so it's very comfortable. I mean, that keyboard, the Atreus, is really nice for that. I mean, it's extremely small, so you might think, okay, but how do you use such a small keyboard? You're missing tons of keys. But the way the layouts are designed and so your fingers are positioned makes it extremely comfortable, and you actually it's less stressful in general than a normal keyboard, in my opinion.
Okay.
Because
how do you use then with your laptop? Then I mean, you're basically bound to your keyboard, right? So that's the pain.
So before the podcast, I had to like take my laptop without the keyboard and go on the sofa downstairs. I mean, typically it was one of these moments, and I have to type on a normal keyboard again. And for a couple of seconds, it takes a bit of an effort to not use your thumbs for a lot of stuff, and it's strange. It's strange to go back, and that's one of the downsides for sure. But and the other goal of Phil was to make it very small, very portable, and because apparently he was going on working from coffee shops a lot and remote places, let's say. So I mean, I could have taken it on my lap right now with me, but I didn't.
I've seen these other guys who use these blank keyboards where they don't have any they don't have anything on their keycaps. It's like this DAS company called DAS make mechanical keyboards.
Yeah, that was one of the precursor of the way of doing things. Well, mine doesn't have any either, but it's not because
it's a security feature, is it? Yeah.
No, but if you, I mean, your wife cannot use it, so for that, no. But no, I mean, anyway, the layout is so weird anyway that, I mean, nobody's gonna really I mean, my mom is not going to be able to use it just by reading where the letters are mostly. Especially the layout I have, because the return key is not even on the main layout. I mean, you don't have a return key. You use Control and M basically to do return. So it's a bit odd. But a lot of shortcuts like this are inherited from all the Unix stuff. So you get, I mean, you got used to these shortcuts before having an Atreus. So maybe the transition was a bit easier. But I don't have tab, I don't have a return, I don't have arrow keys.
No backspace or Control H.
Yeah, no backspace. Yeah, exactly.
Good times.
Yeah. But in the end, seriously, your hands are always on the home row, more or less. I mean, not always on the home row, but they don't move laterally, or almost never. And vertically, they never move. It's just little finger movements. So it's really comfortable, and you can get to very fast typing speeds. And I like it that way.
But I've been thinking, what would be the next way of writing code? Because we've been discussing this a lot at work as well. Like, okay, you have to optimize it a lot. Of course, you switch to one of these fancy keyboard layouts and everything, and for 2 days your speed goes down because you really want to communicate your thoughts faster to the screen. That's the whole idea.
Yes.
I don't know how we are going to solve this, because at some point the keying needs to stop. Maybe we should get one of those brain implant shit or something.
I don't know.
Just keep looking at the screen.
I mean, it's muscle memory in the end. I mean, in my opinion, to be honest, sometimes when some people ask me, okay, well, how do you do this in Emacs with what keys? I don't even know. I just do it with my fingers, and I couldn't tell you which keys are doing what. It just happens. So I don't know. It's probably good enough that way, I would say. But then it's a matter of... Yeah, you wanted to say something?
Yeah, I was going to say, I used to have one of those type matrix keyboards.
Yes.
That was where you have the enter bar in the middle, the enter key in the middle, and it's kind of laid out a bit like, you can lay it out a bit like, you can have it as ZERTY or QWERTY or whatever you want. But again, they're kind of very compact keyboards.
Yes.
So how did you get into this whole keyboard thing then? Because of course, everyone just gets a QWERTY or a ZERTY keyboard the Europeans use a ZERTY quite a lot.
Yes.
But these QWERTY things are a piece of shit, basically. Everyone kind of knows that.
No, I still use a regular layout myself. I still use QWERTY, but the keyboard that's different. I don't use Colmac or this kind of layouts, no. But yeah, it's heavily modified for how I like to use it. But it's not as extreme as, I don't know, I tried Colmac a bit, but I didn't, the learning curve was kind of high. For basically a couple of weeks, not days, you're basically a bit useless with a keyboard, and then you get to it slowly. It's already difficult enough with something with the Atreus. At the beginning, for a couple of days, you're really lost. Typing, chatting is super easy because it's like the layout you're used to. Yeah, there are just 2 keys basically that change. But all the modifier in Emacs, they change positions. You have to get used to a lot of different ways of doing things, especially on Emacs. And it gets worse before it gets better. That's for sure. But then it's a lot better, in my opinion. And it's fun also, the whole electronics part. You get to build it yourself. If there's an issue, you can basically fix it. You can replace the single key that fails if you have to.
So it comes as a DIY pack?
Yeah, that's how it works. So you can order from Phil like packages with, you can have it pre-built for, let's say, a premium price. But otherwise, you can buy for $100-something the whole set and build it yourself. And it's well made, and it's serviceable, and everything is open source, from the CAD files for the plates and all this stuff. The case, and to all the electronics and the PCB and everything.
Nice.
Yeah. And
I should get one of these things these days, because I need to give my Mac for repair because the N key got stuck on my keyboard. It's so fucking annoying. I take it to them, and then they say, "Oh, we need to replace the entire keyboard." What, for one fucking key? Yeah, okay. And then give it to us for 3 to 5 days. And this is the new keys, the butterfly shit, whatever. That's just irritating. So I was thinking I should get a different keyboard, but the main problem is, if you're in a train, if you're traveling, then you get back to this keyboard again. So
that's why I choose that keyboard in particular, because you can. It's really small. It's not is less wide than my laptop keyboard.
Yeah,
It's really compact, and I mean, it's really easy to carry around. And I mean, even if it breaks for whatever reason, or if security on the airport decides that it might be a bomb, it's not too much of an issue like it would be with
exactly.
with others. But yeah, I mean, the ErgoDocs, for instance, that you were mentioning before, you can get a pre-built one. ErgoDocs Easy, I think it's called, but it's gonna cost you, I think, $250 or $300, coming close to that.
Yeah.
And probably even more if you're in Europe. So, I mean, it's really nice keyboard and everything, but I still prefer to have open source hardware for these kind of things.
Yeah. Okay, so this is the keyboard that you use to type all this Clojure code then?
Yes.
In Emacs?
Yes. Yeah, exactly.
It's the triumvirate, the open source keyboard, the Emacs, and the Clojure. I mean, you're living the dream here, Max, really. Well, as far as VJ is concerned, anyway.
I'm salivating. I'm drooling.
Yeah, so we should move on to some of the libraries like you're gonna.
Yes,
suggest.
Exactly. So you use Emacs and then keyboard. So we talked about how, and then now we're going to talk about what. What exactly are you doing these days, and the library that you're working on?
Well,
libraries.
Mostly all the libraries that I've written, almost all of them at least, that are on GitHub. They're libraries that I needed at some point to do something at work. So there were a lot of libraries around Cassandra, for instance. So I wrote I think 3 different drivers for Cassandra with the years. So I started 6 years ago. And I mean, there were drivers, libraries for Java, but they were not very nice to use, full of annotations and stuff like that. And it was kind of a learning, let's say a way to learn how Cassandra worked also for me back then, to implement one from scratch.
I think it could be a nice idea to give a quick overview of what's good about Cassandra and why you started using that one. Yeah,
so Cassandra is a distributed database, but it's very much oriented. It doesn't have a single point of failure in its design, so you can basically every node is equal to another. There's no master or slave or anything like that. And so it's very they say that it's very low maintenance, but I mean, it's partially true. I mean, there's still some maintenance once you grow your cluster past the size, but it's very low operation. I mean, at least when it came out, the big competitor was HBase, and HBase was a monster in terms of installation and maintenance. So Cassandra is very low friction for that. And you use Cassandra if you need to store large amount of data, and if you need a high amount of writes, a lot of writes for whatever you're doing. So it's very good for analytics in general. People use it to store time series and counters about a lot of stuff. To talk about the thing is not really good at, so it's one of the databases in the class, it's AP, I think. So the consistency is not, you cannot have transactions or anything like that. There's no guarantee that you're gonna get through a read what you just wrote, basically. But but other than that, it's it's really resilient. It's never, it's very hard to get into a non-usable state with a cluster, even if machines are down or if you have net splits or stuff like that. Split brains, I would say, not net splits.
Yeah.
And
so where did you use this thing then? So Cassandra is used by your company right now, Finity?
Yes, Cassandra is used in different ways. So we have the company I think has a 40 nodes cluster right now. And there's another one a bit smaller. But overall there are 90 machines that are involved that use Cassandra in one way or another, I think.
Okay.
I don't have the exact numbers.
Do you have this cross data center replication as well in Cassandra?
Yeah, you can have this. Yeah, if you...
do you guys use a cross data center?
No, we don't have cross data center. We are everything, all the main clusters are on the bare metal, on OVH. Okay. So we don't... it's actually a problem because we had an outing recently, and that was a discussion about supporting cross data center replication. But then the costs kind of changes. And we can also use it at much smaller scale. We use it in other projects at very small scale, let's say, and it works just fine. And it was originally by design so that when the setup of a client would grow past a size, you could just easily make it grow. Because Cassandra has a very good thing is that it's very predictable in when you need to scale. If you need like twice the true output, you can just add basically double the nodes and you're gonna get that more or less. So that's one of the really good thing about it.
So how come Clojure then?
Yeah.
Clojure plus Cassandra.
So how come? Well, Clojure was because I just fell in love with the language that I mentioned, and but the drivers were so let's say for Java, and it was a good exercise for me also to learn Cassandra. I said, okay, I'm just gonna write one of these drivers, and it was based on the Thrift interface back then. And there was one only for Java, but it was using the regular Thrift interface, and there was an existing interface using async Thrift back then, so the asynchronous one. And since it was the hot thing to have to be asynchronous and everything back then, I tried. I said, okay, just gonna use that one. And so I implemented part of the protocol for a couple of things like collection types and maps and all this stuff, and all the funny stuff, the retry policies, the load balancing. It's a good experience. I learned a couple of things doing that. And more or less when I was, and we used that driver for quite some time, for a couple of years, and it was doing really well. It was doing okay. Then Netflix came out with their own driver, which was not for Clojure, but for Java, which was really nice, called S10X. So we were thinking, okay, maybe we should transition to this. And then the company that's backing Cassandra commercially right now came out with their own, which became like the official Java driver, and it was also written in a way that was kind of nice and made it a good fit also for Clojure. So that's when I decided, okay, I'm gonna just write a simple wrapper for that one, and try not to grow it too much. That was the original idea, and then it went out a bit of control, and it's becoming what it is now. It's the library called Alaya that's on GitHub. And that's what we use right now. That's at least on the clusters that are running Cassandra 3 point something. That's what we're using, because we're still older installations.
Version.
Yeah.
Okay.
One of the things that you emphasize on the page, Max, is performance. So
yes,
maybe you can tell us a little bit about why, for instance, other Clojure wrappers or Clojure in general might not give great performance by default, and what have you done to mitigate that?
So there were a couple of things. There were a couple of drivers existing in the past for Cassandra, for Clojure, but there was a lot of, they wanted to make a super beautiful Clojure API, which was a nice goal to have, but then there was a lot of, there was a lot of abstraction, and it made things very slow. A lot of intermediaries stuck everywhere, and when I profiled some of them, it was not really nice to see all the garbage created left and right. So one of my goals was to make the Java driver was actually really lightweight and low level. So it was kind of easy to build just a very small Clojure layer on top that basically was a couple of function calls away from the Java thing. And I was trying really not to abuse laziness or sex and all the things in Clojure that can make these things a bit slower. And I just tried to keep it simple, in short. And a lot of profiling also to make sure I was not going a bit too wild in some cases. And the parts that would be slower for one reason or another, like there's another broader library of the main driver, which is like a DSL, a bit like what exists in Clojure for working with normal SQL or Korma in the past. So you can basically use maps to generate your queries. That stuff was all optional. So, okay, that was a bit slower. We do a lot of string manipulations on that one, but you don't have to pay the tax of performance at this level if you don't want to. And actually, we don't really use it that much. We use it just for the migrations and setting up tables and all these kind of things, but not really in the real queries. they all end up being like prepared queries when you care about performance anyway. And and another thing was so there's a lot of iteration, obviously, in this kind of thing. So you're gonna iterate over rows in a table and then in over column facilities that made it really fast. So you can, for instance, iterate over rows using a reducible. So there's gonna be like no cost, no sec created at any point. In one of the ways you can query the database, and also you can do that in some fancy ways. I mean, you can, for instance, do like a select star on the whole Cassandra table that can contain terabytes of data and get a reducible over that and just iterate over the content without holding the head on anything and without, I mean, it's a streaming protocol on the Cassandra side. So it's gonna just come at you as you call the function basically and halt when you want it to halt. And there's another part of the API which is a bit, totally lazy, which allows you really to basically have a lot of fine-grained control over iterations over this data, over your queries, over what they return.
And for the query language, you have your own version, right? For you have your own DSL for this one.
Yes. Yeah, that's what I was saying before. We have a library called Hate, because a Karma that existed that was kind of nice. I mean, the idea at least was nice, but then the implementation was so-so for some reasons. It was a lot of macros, and I don't think there was an intermediary representation also of the queries. There was no data basically that you can manipulate. So the idea was to take inspiration from what Karma was doing, at least at the surface layer, how the API works, but then have just data structures that represent your queries. So you have just maps, basically just maps in short. And you can easily manipulate your queries that way. You just use the normal Clojure function, conj, merge, and all these. And so you can generate prepared statement or normal statements with that. So and also on that side there was a lot of focus on performance, even though I mean, if you really care about performance, you will not generate tons of string. I mean, do a lot of string manipulations at runtime through that library. You're just gonna use that to generate prepared statements and then use the prepared statements instead.
So Max, why do you hate Cassandra?
Why? I'm sorry.
Why do you hate Cassandra?
Well,
what is the name form actually? I don't know. Why? I mean, I know it's not spelled Hayt, isn't it?
AY. No, I'm sorry. The library, the DSL library. You mean?
Yeah.
Hate.
Yeah.
Hate, and it's because the main library, the Java driver is the Clojure driver is called Alaya, which is a character in Dune in the book, and Hate is another character basically in that book, and they have let's say links, and I don't know, it was just a name that I picked like that from the Wikipedia page of Dune.
Okay.
But I'm not really good with naming.
So particularly you hate Cassandra, so you decided to make a plugin, I guess, called
it was
Hate.
not at all the intent.
It's a subtle stab on Cassandra. I think, okay, I hate you, but I'm gonna hate you.
Cassandra, it's a love-hate relationship that we have. That's true also. No, it can be really good and it can be annoying for some things. It's not the perfect solution, and sometimes you just wished you selected Postgres for something instead of Cassandra.
So you also do a library for Elasticsearch as well, don't you?
Yeah, Spandex.
Spandex.
Yeah,
right.
yeah, exactly.
Yeah, like you said, names. Yeah.
Same. I mean,
I'm very impressed that you're wearing spandex for this podcast. That's quite impressive, actually.
I might be.
I
who
think
knows?
you didn't have to wear yellow, but I'm impressed that you did. Yeah.
It was the same situation a bit. I mean, no, it's not really true, but there are some libraries for Elasticsearch, but some of them, they're not maintained really anymore, or they're in live support. I mean, it feels like some of the maintainers just merge pull requests, but there's not really any work done on them anymore. And if you've worked with Elasticsearch in the past, probably know that, I mean, it's a super fast moving project. I mean, every version, they depreciate a lot of stuff. There's a lot of new features, and the low-level bits change, and it becomes really, I mean, even just for a regular user to follow the API sometimes as it evolves, So for the drivers, it was a bit the same problem. And even on their side, the people running Elastic decided to basically ditch because there were two things in the past. There was like the native transport based library and the REST library. So you could choose, okay, I need like extreme performance and whatnot, and I'm going to use the native transport one. Or I can just give up a bit of network latency and use the HTTP based library. But I mean, now with the kind of, with HTTP, you can go very far. And I mean, the difference is not so big anymore between the two. And they said officially not too long ago that the way to go would be to use the REST layer and forget about the native transport, other than to basically build Elasticsearch itself.
Yeah, it's funny, isn't it? Because CouchDB had a REST API from the beginning, and all the Elastic people were, the REST bullshit. Yeah, we want the real native API. That's how you get really good performance.
Yeah,
and they've eaten their words big time.
I mean, the idea, in theory, it's nice to have your own native, your protocol and everything, like Cassandra does. But Elasticsearch is not in a domain where it's necessary to go that, to go to these extremes. And the HTTP also is changing a bit with HTTP 2, and you can get to, very close performance. You don't pay the round trip latency like before, I would think.
What do you do about, because one of the things that they have in Elasticsearch is these aggregation pipelines?
Yes. That's something we use a lot, actually. So just to continue a tiny bit on the on the Elasticsearch part, one thing that was extremely annoying for us is that every time you upgrade your Elasticsearch version with the native transport, you have to upgrade. You have to use the exact same transport, basically, driver. So it was a huge pain. If you have like many different servers for many different clients, like we had, sometimes running still 1.75 because you have to, and sometimes 2.4, and sometimes 5 point something. It becomes a nightmare, and so that's why we decided, okay, we need something more robust. So we're gonna build on the new HTTP client, and since they just released their own and they maintain it, and they do the work with paid people for us, we're just gonna do again a thin layer over that and use that. It's gonna be just fine. So it started as a couple of hours library, and it grew out from there. And so Cassandra is really good at a couple of things. So, first of all, it's not a replacement for a normal database. It's not a database at all, I would say. It's just an indexing engine.
No, you mean Elasticsearch, yeah.
Yeah, Elasticsearch,
Yeah.
So you always have to have some kind of data store in the back that's going to store really what you're going to then index on Elasticsearch, in my opinion. Then it's extremely good at, searching stuff, obviously. And you can express really complicated queries and do like custom weighting on terms or on value of fields, and do really a lot of crazy stuff just for the search part. But there's also the aggregations. So aggregation, you can do very complex analysis stuff that you used to do by denormalizing data, running batch processes in the past. But you can do it live, more or less, with Elasticsearch. So, it's going to cost you a bit more resources, obviously, but you can go very far with what it gives you.
What do you think about this? Because I know DataStax, the Cassandra people, they that you mentioned earlier, they also ship. They have their like enterprise edition of DataStax, and that comes with Solar rather than Elasticsearch.
Yes.
Both based on Lucene in the end, of course. So it's the same fundamental indexing. But what one of the advantages they claim, and I think it's a decent advantage, is that you don't need to move the data around. You can do the searches in place on the data that you've got.
Yes, exactly. Well, they integrate directly with what's stored in Cassandra and gives you like knobs to choose how data, basically how long it lives and so on. But why they choose Solar instead of Elasticsearch, to be honest, I don't really know. And we didn't choose their solution for a couple of reasons. One of them because it's, you have to pay to use it. It's DSC, so DataStax Enterprise.
Yeah.
And it's a bit, I don't know. We used also Elasticsearch in the past, so we just knew how to use it, and it was the obvious choice.
Sure.
And we do a lot of, very often our clients, they have like their own platform with like their own Cassandra, their own Elasticsearch, and their own everything. So if every time we have to pay a license, it would be like a big problem for us.
Right.
And same for Datomic. We even thought about it at some point. Not too long ago, we really evaluated. I mean, in terms of feature, it would be a perfect fit for one of our products. But then, it costs too much, and that's one thing. So
I'm curious about your stack. So you use Cassandra and Elasticsearch. So obviously Cassandra for storing and Elasticsearch for querying, and your own libraries for both using Clojure.
Yeah.
So where is the business logic running? What is the Clojure stack?
Well, the Clojure runs everywhere. That's on the what we call Finity Data, which is like the data platform, the one that does all the streaming aggregation and enrichment, and that's basically the huge data provider for the rest of the clients, let's say peers, as we could call them. It's used everywhere. It's used for normalization of data. It's used for the machine learning stuff. It's used for the enrichment. It's used everywhere.
Which libraries? I mean, do you use any like Spark or something?
Not really. It's mostly Cassandra, Kafka, Elasticsearch, and no, there's not much of
the computation, for example. Do you use Onyx, or have you looked into Onyx?
Yeah, we did. For a project that we had recently, we evaluated it. I was not working on that one, but then they went with a BigQuery just because it was not exactly the same, of course. It's not totally different, but it included like all the operational stuff was offloaded to Google basically, and on top of that you had the data store that was that fit the need. But yeah, Onyx was something that I really liked and that I suggested to the people that were working on that when that came on the table.
Yeah,
and that's a project I would use myself if it's a good fit for whatever we do.
Okay. And the front end is built in ClojureScript as well?
Yes. No, not ClojureScript. Okay. It was at some point very early on. But Paper.li, the other service, is still in Ruby, I think, the front end. But the other products, they're all in Clojure, I think. The backend that serves the HTTP request from the users or the clients. Then it's JavaScript. There's a lot of React. And other kind of frameworks like this, but it's not Clojure. Simply due to the fact that the people who are working on it, they are like JavaScript developers. They're good JavaScript developers. They are very familiar with React and so on. But ClojureScript is not something they would be comfortable using, I think, if we ask them to.
Okay.
Yeah. Or it would take too much time.
In this stack, using Clojure, what was the biggest challenge for you using Clojure? Because sometimes you can pick these days. You have lots of options. Of course, you're also familiar with Erlang, for example.
Yeah.
So picking Clojure, what was the biggest challenge?
The biggest challenge? That's a very good question.
Do you mean challenge or motivation?
Yeah.
I don't know.
Kind of the same thing, aren't they? Really. What did Clojure offer that these other languages made a bit more tricky? Or
okay, that's
if you have to tell your manager, today, can you still defend Clojure as a good choice?
It was the access to a lot of libraries. First of all, access to the JVM, but without having to write 10 times more code with Java, and at the cost of a tiny bit of performance. Not a tiny bit, but at the cost of performance, probably. But we all got extremely productive, I think, using Clojure. And right now, when I try other languages, even like easier, let's say, versions of Java, like Kotlin, where a lot is done upfront by the IDE and the language is a lot simpler, but still Clojure is unbeatable for productivity, I think. Working from a REPL is a huge win over the previous workflow I had. Especially UVI, Max. I have to say.
Yeah,
of course. But no.
You can run a REPL.
It's all because of Emacs.
In fairness, come on.
Yeah. No, but that's productivity was the huge boost. And libraries. So you get access to crazy good quality libraries for everything and anything. Erlang is awesome for a lot of stuff, but you're gonna get constrained to a couple of domains. And you're never gonna do not now, at least machine learning with Erlang, and there are a lot of stuff you have to write it from scratch. So it's good for some things, but not all. And we just use whatever is good for whatever we need to do at a point in time, I guess.
So what kind of machine learning things that you guys use there?
There's a lot of actually custom code. We have a guy who's really good at all this stuff. Well, we can call him like the data scientist of the company. So there's a lot of custom written code, and let me think for a bit. On top of my head, I couldn't give you names of libraries or specific frameworks. But yeah, we use a lot of OpenNLP, for instance, for some things that I wrote.
Because you deal with lots of text then, so mostly text related.
So there's a lot of enrichment or gender detection, all these kind of things, or categorization. And so like also trying to deduplicate content. Since we deal a lot with articles, one of his tasks recently, for instance, was to detect articles that are like extremely similar and that were basically copies of each other.
So you get rid of content farms.
Yeah, exactly. And there are a lot of challenges like this that are not really visible on the surface of what you receive through your data when you're a client. But there are a lot of little tasks like this that require a lot of fiddling with either machine learning or statistics or these kind of things.
So it's like they say then you basically hire a PhD guy and then you have him spending 80% of his time running Perl scripts to clean up the data or their equivalent thereof, in Clojure.
Yeah, that's a bit. No, it's not like it's not as. He doesn't use Perl. He uses Clojure, but but no. Other than that, it's a bit like this. But I wrote a lot of the enrichment stuff also before the merger of the two companies. So some of it was my responsibility, and they use some of what I wrote in the past in the huge data platform now. But it's mostly his work. And that's used for all the rest. That is the big part of the machine learning tasks we have now. Yeah, and a lot of it actually we can. It's not really machine learning, but a lot of very advanced stuff can be done also through Elasticsearch directly. It's not machine learning at all, but you can get really fine-grained precision over what you want from the data through custom scoring and stuff like. It sounds dumb, but you can create custom queries, basically like subqueries that will score your original filtered queries in some ways, and you can go really far with just that.
But I think Elasticsearch focuses on what they call relevance, doesn't it?
Yes, exactly.
And that's it's still magic to everybody, at this point.
Yeah.
There's a lot of maths behind that, isn't there? Yeah.
Yes, sometimes you have to dig a bit into how things work to understand what are going to be the implications in terms of performance or storage about some features. But it's really magic in many ways. It's at the cost of some control. When the person in charge of the data science part really works on this stuff, you're gonna have a lot of guarantees, and you can really tailor-made the solution to what you want to do. With Elasticsearch, you give away a bit.
So do you do only so your system is only processing English language content?
No, that's
or
the
do you
thing.
process other languages as well?
No, that's one of the big challenges. We process more or less anything. So we have clients that are in Spain, in Central Europe, a lot of French, a lot of a bit of everything. We had some national French TVs here and there. So even in Switzerland at some point. So Switzerland is 3 languages. So you start with. So from the start, it was it's a challenge because you find a lot of models that are for English. Pre-trained models for whatever. But as soon as you need Chinese or I don't know.
Even German. Stemming and everything, and that changes the whole.
So you have to do it yourself, I guess. So you find ways to do it. For categorization, the very early versions, we are basically crawling news websites, even though maybe I shouldn't say it. But anyway, we are doing that and through the different categories on their sites to get content that were matching a certain domain, like sport, finance, or whatever. And you train your models on that. But then you use the Wikipedia a lot when you evolve a bit on this kind of websites. That gives you a bit more precision and where there's a lot of freely accessible content. But it's one of the big challenge, finding the data.
So just to move on a little bit, Max, is you've got a very small library, but I think you've done a lot of thinking about it, which is the stuff around spec, because when we talk about data quality, presumably this is something which, in theory at least, once you can start to describe your data a bit better, you
Yes.
should have a bit more power over its entry into your system. So tell us a little bit about how you're thinking about that in terms of its usage in your domain.
Yeah, that's good you mentioned it. We use spec a lot actually, and I was the one pushing it, but because I liked the principle at the beginning. We were using schema before, and I was very skeptical about spec at first. I have to say, I don't know. It felt the way to write the spec was not as natural as the way you would write schemas in the past. Schemas basically, when you were speaking, well, doing a schema for a map, it was a map, and when it was for a set, it was a set, and it was really easy to read. And the spec was a bit, it was different that way at the beginning. So for me, I was very skeptical, but then I started using it, and yeah, I slowly, well, fell in love a bit with the way there's the split between the keys and the maps and so on. So yeah, we use it a lot. We have thousands of lines of specs probably in our code base right now, and it spotted some very pernicious bugs, and we were like kind of amazed by. I mean, we had like very specific specs, for instance, for geographical coordinates that were saying, okay, latitude should be within these bounds, latitude within these bounds. And before we were not caring about that stuff. We were just saying basically, okay, it should be like a number. It was a bit more precise, but it was more or less that. And it was finding bugs, like we had coordinates that were not right sometimes coming from some data sources. And then, I mean, some really weird bugs that we would never have detected were detected by spec. But we are not, I would say, power users. We don't use everything from spec. I'm not using instrumentation a lot. I use it a bit in development, but very often I'm getting bit by some of the shortcomings of instrumentation, I think.
Can you talk a little bit about that? Because I know that, I mean, I like instrumentation when you're doing tests and stuff like that, because obviously it makes it very easy.
Yes.
But obviously there's a runtime overhead. So, and you're seeing some other things as well?
No, what I do usually is basically I create a separate namespace just for the spec, and I load it as I write some code, and I use instrument there. But I mean, but not for everything. But sometimes I have just to put asserts instead of instrument, of using instrumentation. Typically, when I have a higher order function passed to another function, you get to some weird situation where generative testing is going to be called on that function, and then depending on what the higher order function does, I mean the anonymous function that you pass to your function does, it's gonna just not gonna work. When you have to deal with interrupt, for instance, generative testing is either gonna be strange because you have to create a lot of code just to have the generative part works, even if you don't really care about it. And for this, I would sometimes wish it would be a bit simpler, like you would just wrap the function that you pass as an argument with asserts, basically, and do validation at runtime, just as simple as that, like this. But that's one of the things. But other than that, I use assert like everywhere. And the fact that you can enable, disable it at will, and I mean, either at compile time or either at runtime, and this is kind of awesome. And sometimes you just want to enable it even not in production, but in like staging environment, and see where it fails at some point. It's super useful. And yeah, I had a taste of that with other languages I used in the past. And yeah, now it's probably something I couldn't do without. But I'm really looking forward to, I mean, I know that there's going to be a next iteration of spec coming out in the near future. I've heard about Rich working on that. And I'm really wondering what's going to come next, and if there are changes to some of the existing things that I think are a bit, that could be like improved. And yeah. And my other big, not disappointment, but thing I don't really like is the way you compose specs right now. Sometimes you have to get to, I mean, overall it's really good at composition, but sometimes you are in cases where you need something a bit advanced, and you need to compose a lot of specs in weird ways, and you have to use eval because it's all macros, and it's kind of ugly to have to resort to eval to do this kind of stuff. And you just wish you had like a more data, I mean, it was represented more in data than just like forms. And I know that there are tickets about that in Jira. Like they're talking about the possibility to conform a spec and then basically modify it, because then it would be like normal Clojure data, and then unform it and you get another spec. So that would be a way to do it. But it sounds still a bit convoluted, the whole process. I don't know, but I'm waiting to see how it is, and I'm a bit quick to judge sometimes. So we'll see how it is when it comes out.
But did you use any statically typed languages, because to have a comparison?
Yeah, I've used some OCaml.
Yeah.
And I use Haskell as well. But OCaml, we actually have a couple of small things written in it. So yeah, it's very comfortable to have a type system, but you're still gonna generate bugs no matter what. And most of the time,
that's kind of a stupid argument people make, that you're not gonna have any bugs. That's kind of
it's gonna catch the stupid stuff. But most of the bugs that we have, if I look at our issue trackers, it's not because you made a typo or because it's the wrong type of stuff passing here or there. It's because of some weird domain thing that makes it that you missed a case or something like that. But yeah, it helps. And I don't know. I think there's a sweet spot between Haskell or OCaml style static type system and Clojure. And maybe Erlang is like a good middle ground, actually. Erlang has no nil. The data types are fairly simple and use tuples for a lot of stuff. And you have a static type checker that's good, but that's not crazy like what you would have in Haskell or OCaml. And basically, you are almost guaranteed, if you spec everything you write, almost everything, that your code is going to be bug-free and it's going to run just fine for years. It's kind of crazy, the reliability of Erlang code. Compared to even Clojure. But we might just get there with spec, because it's not far from what exists in Erlang.
So it's very impressive. I see the numbers that you're talking about with the Affinity thing. So many millions of articles analyzed, and a different amount of data that you're analyzing. So I have two questions surrounding the Clojure. Look, do you have any estimate on how many lines of code that you have in Clojure, and then what is the team size?
I have no idea about the lines of code. It's a good question. I seriously, absolutely no idea.
No, if you take out all the libraries that you wrote and then released.
There's a lot of them. It's probably in like 50 libraries, probably. I don't know. We also use Git for like configuration, so there's like hundreds of them, but there's probably in the 50 of real libraries, I would say. And then the number of people, before the merge, that was just me working on Clojure stuff. Then when we merged the team on the other side, there are two people, almost three, I would say, that work with Clojure, but really two full-time. And and they inherited from code that was written from other Clojure developers. Also, the team changed a lot on the other side of the company. And it's all people from Switzerland that are still working with Clojure for most of them. And so I've heard about one of them, had one of his projects presented at the huge AWS conference not too long ago, showing off another Clojure project he's working on now, which is kind of insane. That was Olivier.
Written in Clojure, yes.
Yeah. And I don't know exactly what they're doing, but it's probably very impressive. And the other team is the guys behind Exoscale, which is a hosting provider in Switzerland, which are doing also, a lot of good stuff. It's a bit similar to DigitalOcean in the way the service works, but with other selling points, and it's super impressive what they're doing. And that's mostly, I know Pierre Richard that works there, and I don't know about the others. I know a couple of them, but from Python, they're mostly from the Python world, from what I know.
We'll talk to him in the future because I worked there for a while, so we'll leave that one for another episode.
Exactly, yes.
But it is pretty impressive with the stack that you have, and with the Clojure is running behind this big organization, and it's usually you don't get to hear these things much, right? That is the interesting part. When things are running smoothly, nobody complains, so nobody knows that what is happening.
Yeah, it's true. It's not a lot of people for a lot of work when you think about it. It is true. But Clojure makes it easy to iterate very fast. We did a lot of stuff. Small projects that failed also in the past on both sides of the company, and it allows you to do that without losing too much, I would say.
And how do you deploy the? Let's talk about the final stage. So
Yes.
you write the code, and then you spec it, and then you make sure that it's bug free, and then now you need to deploy the code.
There are two ways of working. What I call our side of the company, even though it means one company, one team now, but on our company at the beginning, we use Ansible, but there's a whole, you pass by CI, and then Jenkins build the stuff, and then we have our own internal tools to do deployments and to follow the life cycle of every deployment for the clients. So tools written actually in Clojure and Clojure script. That's the exception for Clojure script. So yeah, and on the other side, they use Palette, which also is written in Clojure, which is an orchestration library, which was a bit inspired from probably Palette, Chef, all this stuff. But that runs without an agent also, which is a bit more like Ansible that way. So yeah, that's how it works. And the infrastructure, I think, is like 90 servers on one side and around 50 on the other. And 90 bare metal and 50 that are split between Exascale and DigitalOcean, so it's VMs for the other side. So there's a bit of everything. It's like fairly automated.
Impressive.
Yeah.
But you do your own hosting then? You mostly build your own racks and do your own things?
No, it's on OVH. When I say bare metal, it's not VMs. Okay. That's what I mean. So it's basically cheaper infrastructure and a bit better performance depending on what you do. All the Cassandra, the important Cassandra clusters are all on bare metal, for instance.
Oh, right. Okay. So it's a rack somewhere in a cave.
Exactly. Yes.
Yeah.
Okay, so that's a pretty impressive explanation of. I've never heard that this is Paperly was built in Clojure. This is the first time I'm hearing it. So that's interesting for me. And of course, now I see the bigger picture. Now it makes more sense. And it is impressive to hear that Clojure is being used at this scale. And that is pretty awesome.
It's also quite one of those things where you hear people talk about the sweet spot for Clojure is big data, but then everyone's saying, but where are the examples? So it's quite nice to hear a good story, a good example. Like you say, with very few developers, moving a lot of ground, pulling up a lot of trees. So that's quite impressive.
There are a lot of projects, I think, that are probably low profile and that we don't hear about that are running Clojure behind the scenes. Even some of the developers on our teams, they are not people that are like Clojure famous, let's say.
Sure.
They're not writing tons of Clojure libraries and they're not on Slack all day. But they're still extremely talented. They're really good programmers and they're, you never hear about them, that's all. And it's probably not the exception. It's probably the rule, actually. And so, it's too bad that some projects they don't come out more in strength talking about what they're doing publicly. That's true, but I don't know. Maybe it's something that should be improved via conferences. Podcast is a good way to do that also.
Yeah.
We're
trying our bit.
Yeah.
Exactly. But this is why we want to talk. People who are so metaphorically speaking, neck deep into Clojure, and then they're using Clojure to build these kind of awesome things. And of course, I knew about you when Ray was mentioning about Cassandra library, but I didn't know that you are part of this. There is a huge iceberg, and the two libraries were basically like tip of the iceberg, so to speak. So it's very nice to hear, and then it's very motivating for people who are listening as well. They're like, oh shit, we can do all this shit in Clojure. That's
when you think about how it started also, basically I was just toying with Clojure on a small project on my side, which became a product, which became a company, which merged with another one, and so on and so forth. So in the end, it don't need much, and small things can become bigger.
Fantastic. Hey,
right.
So I think we are almost 1 hour into the recording, but very very insightful discussion for me at least. Now I can talk about you can use Clojure for big data stuff. It can't get bigger than this, right? Bigger as in, of course, you can keep adding more and more websites and everything.
Yes.
But almost 50 million websites and blogs. It's a big beast, I would say. So any conclusive thoughts?
Good question.
Did we miss any of the kind of areas that you wanted to chat about, Max?
Let's see.
Excellent.
Perfect. Otherwise, you need to come back and then we need to do another
So. I
episode.
think we covered it all, really. Yeah, exactly. No, I'm months about what would come out in Clojure. It was a bit like the Steve Jobs effect at every Clojure conference, and we have a bit less that. And I think there is some talk about Clojure popularity slowing down. I don't think it's really true in the end. And I think it's good that you're doing this podcast, and I hope more people like push the envelope and show what they're doing, and so that popularity keeps growing. And
yeah,
well, do more of this.
I was going to say it would be very welcome for people to talk to us on Slack or on Twitter, because we have a kind of process for getting people onto the show, and often it's just me or VJ liking a look of people or liking a look of repositories and hunting around for people, and that's fine. It's all working out quite well. But definitely shout out to the gang out there. If you want to talk about a project on what's this called again? It's called Defen. Yeah. If you want to talk to somebody about on Defen, we're quite welcome. Yeah.
Yeah.
Yeah. Of course. I mean, this is how we want this podcast to be. And not only just people who are already in the conference circuit and doing their bit to encourage Clojure usage, but also we would like to talk to people who are every day getting things done with Clojure, and then what kind of challenges that they're facing and what kind of advantages that they have compared to the other development teams, and how happy they are. That's the whole idea, right?
Yeah.
And of course, as Rich was mentioning, I think it was for the boring people. Clojure is for boring people who want to get shit done. So that makes more sense.
Yeah.
But
that's exactly it.
Okay, so I think we can conclude now. Just before we close off, we'd like to first of all, Max, thanks a lot for joining us.
Oh, you're welcome. Thank you.
It was a pleasure talking to you, and we hope that you're going to use Clojure more and more, and then grab more and more. Keep adding zeros to your numbers, both to your posts and also hopefully your company financials. Who knows?
Thanks. It was a pleasure being with you. Thanks.
Yeah, it was really, really fun. And obviously, I mean, we just want to thank the people who are already supporting us on Patreon. There's already 6 patrons for us, and we are extremely happy to have your support. And I've already ordered my Tesla with your money, and I'm going to send it to Mars right after Elon Musk sends. No, we're going to order a Tesla and then send it to Mars, right? That's the idea.
Oh, yeah, that's right. Yeah.
That's what Elon Musk is doing now.
Yeah. So that's all that cars are good for. Yeah.
Exactly. But all the jokes aside, I mean, we very much appreciate your support, your patronage, and please keep checking your private feed, because I'm sending some messages to you folks. And the people who are not on Patreon, this is a slight nudge to you that you might get more information if you become a patron for us. And of course, the usual credits. This is me from Holland, and Ray would do the honor for our rest of the crew.
Okay, from Belgium, yeah. Well, we got the music from Pizzeri, and he's got the famous melon hamburger coming at you right now, I imagine. And and we have Wouter doing the sound editing for us. And just a small final word, by the way, we're all going to be doing a Defen road trip to Clojure in Germany in February.
Yeah.
And so that's going to be really good. If anybody's going to go to Clojure D, if you can hit us up between now and then, that would be really excellent. So myself, VJ and Wouter, we're all going to go, and we'll be there in force, and hope to see you there.
Yeah, and okay. I mean, we'll probably try to record something there.
Definitely.
Or in the worst case, if we are going by car, which I don't, we will be, but then we'll start recording in the car and then annoying people. Ray is already like, there is no way.
There's no way I'm driving to Berlin. No way.
But of course, I mean, if you're popping by Clojure in Germany, hit us up, and we would love to talk to you. And then, and we know that our biggest fan base is in Germany. So
Exactly.
that's this is like we're gonna be autographing everywhere on the streets, and we're superstars in Germany apparently. Okay, that's it from us for today, and we will come back to you with another episode soon. And we wish you good luck with Advent of Code if you're participating in it.
Yeah.
Keep writing Clojure, and again, thanks a lot to Max for joining us from Sweden. And good luck with your Clojure stuff. Bye-bye.
Bye. Sorry. I'm allergic to Linux.